Okay, class, I'm Professor. My name is Roman Luco, and this week's flight presentation is going to be the scenario called Flying Wild. So, as stated before, this will not be a talk line by line presentation, but for the scenario, I do have to lay out a couple things. For the scenario, I'll be checking out in the Flying Club Twin. After completing the checkout, you want to take a trip into the wilderness area, which is located in Rolling Hills in a neighboring state. For your trip, it will be a nice summer day, but you will have various field elevations. You will have little twin time and no time in this make and model airplane. So, for this situation, I'm going to set up a scenario close to where I live and a situation that I may actually be in the near future. So, the aircraft I'm going to be flying is going to be the Piper Seminole. I have no experience in the Piper Seminole at this point. I've been flying the DA Diamond 42, which is a multi-engine aircraft as well, but it has a full authority digital engine control system. And with the Piper, it has a mixture. So there's going to be slight differences in terms of controlling the aircraft, especially the prop governing process of it. Once again, it's a light twin. Its max range is 700 nautical miles. The service ceiling is 15,000 feet, and that's going to be important for our route, especially the en route portion of our flight. Takeoff distance is going to be 2,200 feet, and our landing distance is going to be 1,490 feet. Now, of course, those numbers are going to vary based on density, altitude, things like temperature, and weight and balance is going to come into consideration with that. But those are just some general numbers to live by in terms of quick planning. So, one of the most important things you need to do is pre-flight. Pre-flight planning is important. Of course, you want to do the weight and balance. But when you know you're going to be flying over terrain that's varying, you need to make sure you have a great idea of your aircraft's climb performance and also its single engine performance. So what I have here is laid out is two charts. So the climb performance with both engines with gears up and climb performance with one engine operating gears up. So obviously when I'm doing my weight and balance, I'm going to get my center of gravity set up, get the density altitude, and then at that point, I'm going to go to my performance charts and I'm going to look at things as terms of temperature, altitude I'm going to be flying at, pressure, altitude, and then make a determination of if the flight is even going to be possible today. Because when I'm in these high altitude areas, you have to make sure that you're within the aircraft's performance capabilities. Because you can't take off in an area where the altitude exceeds the aircraft's takeoff capabilities. So we'll be unadvisable in that situation. And going into single engine performance. So the major thing about flying a multi-engine aircraft is understanding that when you lose an engine, you're going to lose 80% of your performance. So 50% of power and 80% of performance. So single engine climb, it's going to be very limited as opposed to having both engines because you're losing a lot of thrust and power. So with that single engine performance, one thing I want to note that for this aircraft, there is no single engine climb rate required. But we need to be aware of our single engine service center. And what that is basically the aircraft can climb at least 50 feet per minute at that altitude. And the next thing I need to be aware of is the single engine absolute ceiling. And so basically that's the altitude where on a single engine the aircraft can no longer climb. Some people also call that the drift down altitude because if you have a single engine failure above that altitude and you lose an engine, the aircraft's going to drift down to that altitude regardless if you're climbing at blue line, which is going to be your single engine best climb. So we have those things laid out. One of the next things we want to go into is where we're going to be flying. So in this situation, we're going to be flying in the rolling hills and the actual rolling hills in California. So we're going to depart from San Diego, and the elevation there is only 17 feet AGL. So when I take off my Aroca, which is going to be the off-route obstacle clearance altitude, is going to be 19,000 feet. Then en route, we're going to go to Ontario. And the reason we're going to go to Ontario is so that we can avoid the Class Bravo airspace within that route. And then our arrival is going to be in San Jose, and it's going to be an elevation of 510 feet. And our off route obstacle clearance is going to be 1,600 feet. But the most important thing I want to note is in Ontario, the off route obstacle clearance is going to be 9,200 feet. So that's going to have to put us at a way higher altitude. And then we have to consider we're flying on a westerly path, so we need to be at 10,200 feet. So we need to make sure that our aircraft has the performance capabilities for that area. Now, let's talk about what happens if we actually lose an engine when we're in that area. So what I have here in the chart is the one engine inoperative procedure. Now, I'm not going to go over every step, but the important thing I want to lay out here is that it's going to be different than in the aircraft I've been flying. So one of the main things that's going to be a little different is the mixture. So inop engine mixture. It's saying cut off the mixture. So for me, typically what I do in the Diamond DA40 is I just pull back the throttle and then I cut the engine off. The ECU, which is the engine control unit, does everything else. It feathers the prop, it gets everything else set up. So as long as I do the basic maneuvers and get to blue line, the aircraft's going to do most of the procedure and make it a lot easier for me to handle that emergency situation. So when I'm flying in this area, I think the biggest thing I need to understand is I need to be aware of the aircraft's capabilities. I need to be aware of its limitations in terms of ceilings, and I need to be very aware of the one engine in out procedure. With that being said, like I said, it should be a relatively easy flight. Like I said, it's not a real scenario, but based on the information we have in the area we're going into, I just need to make sure that everything regarding the aircraft in these high altitudes I'm really aware of. So my references are going to be the Airplane Flying Handbook, the Pilot's Handbook of Aeronautical Knowledge, and a new reference is going to be the ATP Piper Seminole Training Supplement. So once again, thank you for listening to my presentation, and I hope you all have a great day.